Hi, software engineers. Now coming to you from the Flower and Garden Festival here at Epcot at beautiful Walt Disney World. More places I'd love to be, of course. Hope you're doing well. We are now moving past software process, software methodologies, moving into the first phase of development. So this second unit in the course is all about requirements and requirements engineering, and that is exactly what we're going to get to today. So requirements engineering is actually a subfield of software engineering, where the basic idea is, how are you going to go about understanding what it is you actually need to build? Now, if you remember my story that I told during one of the online meetings, but it's also posted at cs3240.cs.virginia.edu, I worked on a piece of software for Appalachia Service Project, wonderful people, back in the summer of 1999. And long story short, over 2 decades later, I'm still performing maintenance on this piece of software. Now, your software will haunt you is a little hyperbolic, obviously, but the point being is that the cost of software is not in the actual building of it. The cost of software comes in the maintenance of it, in the keeping it working, in the keeping it running. So this is my first rule of software. Whenever you're building a piece of software, make sure you're thinking about, well, how is this going to live into the future? How are we going to make updates? Who's going to own it? How is it going to be changed? All of that stuff. Be thinking about that, but because that's really, really, really important. So let's try to figure out the second rule of software. And for that, I want you to take a moment and think about this. Let's think about a student organization, a CIO at UVA comes to you and says, hey, can you build us a website that allows students to sign up for events? Let's pretend they're virtual events right now that they're putting on. Seems reasonable, right? So what I want you to do is hit that pause button, take one moment, and I want you to think about this, okay? What would you do? What would you ask them? Are you thinking? You still thinking? Let's go. Okay. Now, you might ask them, how many people will use it? You might ask them, does it need to be behind NetBadge? You might ask them, do they need to pay anything to register? You could probably come up with several questions. Probably the most important question is, can you just use a Google Calendar? Can you just use a Doodle app? This is a solved problem. Do you really need to rebuild new software? Do you really, as a software engineer, need to go off and make something brand new when it kind of already exists? Which comes to Sherriff's rule of software number 2. Make sure you're solving the right problem. It could be that you as a software engineer get, given a problem and you get super excited about, oh man, I can't wait to build this in React and have a JSON REST API, and it's going to have a mobile front, and you just get so excited about all the cool stuff you're going to do when all you really need to do is help them set up a Google account. Yeah. We get super excited. We get super excited about helping people, about doing this cool stuff, but we need to focus on the customer. We need to focus on the stakeholders. Our role as software engineers is helping other people do their jobs better, live better lives, do whatever it is they need, solve their problems, help them solve their problems. Now, we don't necessarily know all the domain knowledge that we need to solve every problem. This is one of the reasons why we like it for you to take a lot of HSS courses, so you can, hey, I had a class in economics. Hey, I kind of understand sort of what's going on when you go work at like Capital One or something like that, maybe. You need to understand what their problem is. You need to talk to them. You need to get a feel for, well, what are we trying to do? Are we trying to make, build the latest, greatest, newest, and most amazing thing? Or can we just use something that's already in existence? So we're trying to get these software requirements out of the stakeholder. So a software requirement, a condition or capability needed by a user to solve a problem or achieve an objective. This is what the software has to do in order for it to be successful, right? It has to allow me to record people's address. It has to allow me to upload to a server, whatever it might be. Okay? Must be met or possessed by a system or component to satisfy a contract, standard, specification, or formal constraint. It could be that because it is a particular type of security software, maybe it has to meet some sort of standard. Maybe because it's medical software, it has to have certain sort of redundancies. These are all requirements on the software. I love this quote from the pragmatic programmer. Requirements are often buried deep beneath layers of assumptions, misconceptions, and politics. We as software engineers tend to think we might know more about someone's problem than we actually do. And that leads us to make guesses about what the customer actually wants or needs. And this leads us to build the wrong software, or build something poorly, or build something that doesn't meet the actual need. We need to learn how to listen. We need to learn how to actually have a conversation and figure out what the needs are. Never assume you know what the customer wants. Never. You need to be an advocate for what you think they need, but have that conversation and understand what their needs are. So requirements engineering, the systematic way of developing requirements through an iterative process and analyzing a problem, documenting the resulting observations and checking the aggregate. Yeah, basically the same ideas that we apply to software engineering versus coding, right? Coding is, I'm going to go in and slam out some code in VS Code and make something appear on the screen. 2 thumbs up. That's awesome. Software engineering, the systematic way of building software so that it's meant to last, so that you make sure you take into account everything you need to understand. Requirements engineering, the programming version of that is walking into a room and saying, hey man, hey ladies, hey everybody, what is it you need? And I'm just going to write it down on a piece of paper, cool, and I'm going to go start slamming out code. Requirements engineering is a systematic process for how do we sit down with the customer? How do we tease out what the need is? How do we understand what we are going to build? So requirements engineering is an entire subfield that does really cool stuff. What we're going to talk about mainly is just kind of the basics of what every software engineer needs to know, and that is requirements analysis and requirements modeling. So requirements engineering is basically broken into two phases. Great, more phases. Thanks, Sherriff. Yeah, I know. Okay. Requirements analysis, also called requirements elicitation, is the act of studying the needs to get the definition of a system. Part of it is interacting with the customer. Part of it is looking at what is in the market. That's one part. We're going to talk about that in a second. The second part, requirements modeling or requirements specification. That is the translation of what you just did in requirements analysis and elicitation, gathering the information and converting it into something that a developer can act on. You know, if someone says, hey, I need you to, build this secure, that's a bad example, but sure, build this secure, what does that actually mean? What are we actually programming? So requirements elicitation, the process of gathering requirements from the stakeholder. Now, the definition of stakeholder is any entity or representative of a group that has a vested interest of the system. I want you to pause one more time, and I want you to think, well, don't pause just yet. Let me ask you the question. Who are the stakeholders for SYS? Who are the stakeholders for SYS? Who are the people that have a vested interest in the system? Okay. You still thinking? How's that thinking going? Okay. Students, because you use SYS, obviously, for signing up for courses. Administration, for administrative things. Finance, the registrar's office. Faculty advisors who have to go in and, like, when I log into SYS, I see a completely different SYS than you do. When I go into SYS, I have the ability to go in and remove holds and that sort of jazz. I don't have a finance tab. My finance stuff is in Workday because that's where I get paid. So I don't see any of that in SYS. But there's other stakeholders, such as the board of visitors, the university system. These are all entities that have a vested interest in what this software can do. So we need to build software, or in this case, purchase software or customize software that has to satisfy all of these needs. How do we do that? Who matters more? Who matters less? Who do we listen to more? I know what you're going to say. They don't care about the student. I mean, they did have to look at the student interface at some point, but I could make the same argument for faculty. So they had to consider things, though, that you might not think about, like how robust is the software against failure? We can't lose people's student records. We can't. So we need to make sure that we are picking the right solution that handles those problems. So once we know who we're going to talk to, who these stakeholders are, what are we trying to get out of these individuals? Another classification: functional, non-functional, and constraints. Functional requirements, non-functional requirements, and constraints. Let me just go ahead and jump to them one at a time. A functional requirement is exactly what you think it is. The system shall something. The system shall allow user to log in with a username and password. The system shall allow user to post a message that on the message board that anyone can read. The system shall allow a faculty member to remove a hold from a student. The system shall, etc., etc., etc. As much as possible, a functional requirement needs to be specific and unambiguous, measurable and observable, and testable in some way. So let's think about this for like a music player, okay? If I just say the system shall play music how? Play music when I shake it? Play music when I press a certain button? Play music when I sing to it? That's not specific enough. The system shall play the current loaded song, or the first song. Let's say that the system shall play the first song of the current playlist when you press the play button. That's more specific. That's something that's observable. If I press the button and it happens, okay, I tested it and made sure it happened. But if I just said the system should play music when? I press the button and it starts playing music 10 days from now? These are obviously silly sounding, but this matters. How about a to-do list? The system shall allow user to record a to-do. Again, how? Why? How does this operate? Do I have to get down to the nitty-gritty of it to say it will record a to-do as an XML document that then is stored? No. That's actually called implementation bias. When you put that sort of information into the requirement itself, you are trying to tell the programmers how to do their job as a requirements person, and that's not what you want. What you're trying to capture here is the functionality. The system shall allow you to mark off a to-do item by tapping the name of the item. That's a good one. Text editor. The system shall underline misspelled words according to the dictionary loaded. I don't want to give a specific dictionary, that's implementation bias, but a loaded dictionary, something like that. Okay? These are all things that if I read it, if you read it, if the programmer read it, we would all have a similar understanding of what the requirement is. This is really, really important because so much about software engineering boils down to clear communication. Can we understand what the customer needs? Can we then translate that to something that the developers can build? Can we translate that into something that the QA folks can test, that we then can show to the customer or other stakeholders at the end? How do we understand what we are building? And we're going to talk about communication throughout the entire semester and how important it is. Not only for the building of understanding the software, but communication like in your teams, with management, all of that. But here, it's communication in the respect that, am I as a requirements engineer listening to my customer enough that I can write down plain language requirements that I can then show them and say, this is what I think you mean. Am I right? And if they say, yeah, that's awesome, yes, I got it. Now your job is to clearly communicate that to the developers. It's like the weirdest game of telephone you've ever played. That's why we have these processes, to try and make sure that we can pull this off. So these are functional requirements. These are the things that the system does, right? It is a functionality. Contrast that with non-functional requirements. Non-functional requirements are harder to kind of wrap your head around because they deal with aspects of the system that aren't localized to a feature per se, to a button, I guess, right? So I want the system to be secure. Great. Everyone wants that. But there's not like, let me import security module and it just does it. Security is something you have to think about throughout the entire process. It pervades all of your features, right? Privacy, same thing. How are you protecting people's data? Usability, accessibility. What color schemes are you using? Are you making it able for screen readers to work with? Are you making it so that colorblind people can understand what they're seeing? For instance, example there, you might have, it needs to be accessible for colorblind people. One thing that you might do is for certain colorblind, like whichever colorblind type someone is, to use an icon with a color so that when someone who is colorblind looks at a button, looks at some sort of action, there's both a picture and a color that can be used to identify the functionality. This is actually very commonly used in board games, believe it or not. Go look at Ticket to Ride. The colors on each of the train cars also has a symbol. I'm diving into a different topic, but that's not something you just do one place. There's not the universal make work for colorblind button that you do. Reliability. Did you build your entire system to handle 10,000 simultaneous requests? How are you handling that DevOps process so that your servers can handle more traffic? Availability is the same thing. Performance, same idea. How robust is your system? It's not that you just did it right in one spot. A non-functional requirement talks about the state of the system. It talks about how did you build the entire system with this concept in mind. So these are probably, a relatively exhaustive list, but you can probably think of some more. They are not limited to one function, not limited to one class. These are things that come up when you're talking to a customer, to a stakeholder, and they say, it just needs to be secure. It just needs to be fast. Well, what's fast? You want every requirement to be specific, unambiguous. So fast might be a page loads in 100 milliseconds. Now you have something you can test. Okay? So even with NFRs, you as much as possible, you need to have something that can do a test. For things like usability and accessibility, there are tools out there, web tools, that will go through a web page and see whether it would pass a screen reader, whether a screen reader could handle it or not. Something you should think about. Okay? If you do something wrong in an NFR, if you're not thinking about that NFR from the beginning, you might have to redo your entire system. So if, for instance, you pick a certain framework or a certain platform or a certain algorithm, and it has to handle a certain number of transactions per minute or per second or whatever metric you're using, if you get it wrong and then you build out the system, you might have to rebuild the system. So the point there at the bottom, working with the customer to figure out your NFR requirements, that was like ATM machine, your non-functional requirements as early as possible is really important. How secure does this piece of software need to be? How reliable? How available? How fast? What are the conditions under which this piece of software is going to run? So think about in terms of SIS. We can talk about what does a student need to do when they log into SIS? They need to register for courses, pay for their bills, yada, yada, yada. But then we also have to think about what happens to SIS during the weeks of registration. How many concurrent users can it handle? No jokes. How much uptime does SIS need to have? You get the idea. How secure does SIS need to be? Those all things you have to think about. How is the software going to be used? Because if you don't, then you get in a problem. Like for instance, the healthcare example as well. They didn't think as much about those concurrent users for when it was really getting hammered. The last type of requirement is a constraint. So a constraint is something that it's not an NFR, but it limits your options for how you build the software. So the best way to think about it is, because of the infrastructure at a company, they say this has to be written in C#, C++, Java, Python, whatever, because once you as a software engineer are done with it and you've turned it over to them, that's what their development team knows, and that's what's going to allow them to perform maintenance on their own. So a constraint is you need to build it in a particular language. A constraint limits your solution space, saying you must use this library, you must use this operating system, you must use this programming language, whatever it might be, okay? So NFRs are not constraints. Constraints are not NFRs. Constraints limit your options for what you can build. So I know you haven't gotten your project design, you probably haven't, depends on when you watch this, I guess. You don't know exactly which project you're doing yet, but just think in general for the projects that we're talking about, what are some examples of functional requirements, non-functional requirements, and constraints? Let's do the easy one first. You have to use Django. You have to use Python. You have to use Heroku. You have to use GitHub. Those are constraints that we have put on you for your solution space. You can't go off and build this in Ruby on Rails. That's an unacceptable solution. Now, do we say you have to use Bootstrap? No. I think that's a good option, just for, learning web development's sake. Learning Bootstrap's not a bad thing, but some of you might say, no, I'd rather do this in React or whatever. Great. That's not a constraint we've put on you. But that's an example of a constraint. What's a non-functional requirement? Well, how secure does this need to be? Because it's a class project, we want you to think about these things, but we're not going to super enforce you must handle 10,000 concurrent users or anything like that. We're not going to super enforce things like it has to be such and such secure. I mean, there's some level of security we will expect. So I guess there is a notion of it, which it must be protected by a Google login. Non-functional requirement. When you go to a page, you got to handle that. The functional requirements are what the system is going to do, right? Anything like a user has to press a button to do a thing, that's going to be a functional requirement. So that's the basics of what requirements engineering is. It's the idea that we're working with the stakeholders to help them understand what their needs are, making sure we are listening as much as possible. Communication is so important here. And teasing out those functional requirements, the system shall, this is what the system will do, the actual measurable, repeatable, unambiguous things. If I press a button, this is what happens. The non-functional requirements, the state of the system, how reliable, how accessible, the usability, and then the constraints. How do I limit my design space? I have to use this programming language. I have to use this library. So that's a good place to stop with this video. Next time, we'll talk more about the specifics of how you actually go about eliciting those requirements. So until then, from Epcot, hope you're having a good day.